All right, good afternoon, folks. So today we're going to continue with our sort of particle stuff. There's a couple things that I want to mention first. So I put another video in the other resources section on Blackboard. This is a video of one of the technical artists at Blizzard who worked on Diablo 3. This is from GDC, so similar to the Diablo Classic Postmortem one that's in here as well. But this one deals with Diablo 3, so the most sort of recent, at least recent released incarnation. In here, because it's a technical piece, he does talk about the particle systems that were used, and also shaders that were used for those particles. So it gives a little bit of insight, which is always why I like watching these types of videos, into how they created the effects that they did. So things like the fire on the ground in the game, things like the spell effects, stuff like that. So it is a good watch. He gets to some of the more sort of technical stuff about midway through, is when he starts sort of going into some of the more technical aspects. But it ends up being quite amazing that what they can do using so few particles. We probably had in the particle system we were messing around with last time. We probably had, I don't know, maybe hundreds, maybe up into thousands if you change some of the settings. Oftentimes, the effects that you saw in Diablo 3, if you played the game or watched some videos on it, oftentimes they're less than 20 particles per effect. So there's some really cool stuff that they do. And based on the video a little while back, when I'd first watched it, I'd reproduced reproduced the technique that he used. So that he talked about in the video. So I don't know exactly how choppy this is, but it is sort of a nice sort of smooth flow. This is only about 25 particles, and it uses the technique that he talks about. Some of that is shader related. We will talk about Unity Shader Graph in a few weeks, but I use Shader Graph to reproduce a shader he talked about, and the techniques for the particle systems. And really, it's just a standard particle system. It's the same type of particle system we saw last time. And all I use is emission, shape, color over lifetime, size over lifetime, rotation over lifetime. That's it. So some of the features that we saw last time as well, that's all I'm using. And things like color over lifetime, they can really change the look of what this particle system looks like. So there's some really cool stuff you can do with sort of very simple particle systems. So again, there's only 25 particles, but it looks a lot more complex than it actually is. So I just wanted to mention this to partially to maybe hype that video a little bit, because it is really cool to see some of these visual effects and then realize that, hey, it actually wasn't that hard, and I could probably do that in Unity. So when you're playing other games, you see some kind of visual effect happen, it might be worth a little bit of thought about, hey, how would they do that? How would I do that with the Unity particle system? How could I make a quick texture or stuff like that? And really, all this is just a noise texture, a couple of noise textures that are moving over each other. That's the shader part. So yeah, there's some really cool stuff that you can do. So I do recommend watching that video. There are others as well from GDC about visual effects stuff too that you can watch. But I did like the Diablo one talking about some of the effects that they use, and actually showing some of the technical work in the shader and the particle system about how they actually did it. So I wanted to mention that. Real quick. There are two pieces that we're going to work on today. I don't expect today's lecture to be super long. I'm going to close out of Unity here. I don't expect today's lecture to be super long. The main part of the lecture will be the visual effects graph. It has a lot of similar concepts to the standard particle system, and in fact, we're going to make something that looks kind of like this. This is an image from some of the Unity sort of advertising stuff for the visual effects graph. We're going to make something that looks very similar to this in sort of our own way. It's not too complicated, but it does use some sort of extra math stuff that we're going to do in the visual effects graph, and some of the standard stuff like color over lifetime, for instance, that we saw in the traditional particle system. The other part of today, which is what we're going to do at the beginning, is just a little bit of cleanup on the stuff that we didn't finish last week. So it was just a couple of slides, just dealt with a little bit of damage stuff. So I am going to open up the my Volcano Island project. In the meantime, for Visual Effects Graph, I do recommend grabbing under lectures for week 4. I put a GitHub project here. This is essentially the starting place for the Visual Effects Graph. It's basically just an empty project, but it's using the high definition render pipeline. So you can create a new project with the HDRP, but it imports a whole bunch of assets and a whole bunch of test stuff that we don't necessarily need. So I just created essentially an empty one that has the HDRP sort of active and stuff, so that we have a nice, easy starting place so you don't have to do anything extra. We will talk about the render pipelines later in the semester, but that's something that I didn't really want to get into at the beginning. So if you want to clone this project or whatever, just make sure you have it sort of ready to go. The first thing I want to do is open up Volcano Island so we can just add a little bit to what we have. So here, I'll take a moment to load up. If you do make a new HDRP project, it does take a few minutes to load everything, because it loads a bunch of assets and it sets a bunch of stuff up for you, which is good, but it takes a little bit, and you don't need all the stuff that it sets up to do some of the visual effects stuff if we're just messing around with that. So I'll wait for this to load. Essentially, today is really just messing around in the player class and messing around in the enemy class. And so we're going to talk a little bit about those two as we go through on our project here.
Sorry, are we going through the old project, or the one you told us just to?
So for the first piece, for the first few slides, it's going to be the Volcano Island stuff that we just that we were working on last week. For the visual effects one, that's that empty project that I put up for you guys to download. So while we're working on this, you can make sure you have it cloned and essentially ready to go. So for the Volcano Island one, for the scripts, I'm going to open up the player and the enemy script. So make sure to have both of those open. And again, this is stuff that we didn't quite finish last Thursday. So the first thing I want to write for the player script is just a function to take damage. That's all. So we're going to take the health. We're going to subtract off whatever value gets sent into here. And then if the health drops to less than or equal to 0, then we're going to do set active false. And I'll remind you what this set active thing does in just a second. So the player is going to be controlling this take damage thing. So it's going to be part of the player class. So essentially, to make the player take damage, we're going to need to have a reference to the player and then call take damage on that reference. Set active, setting it to false, will cause the player to disappear. It'll cause the entire game object to disappear. So that's what we want. So I'll show you what the equivalent is in the inspector. But this is basically what we're going to write in our function here. So in the player class, I'll just put it down below here. We're just going to have public void take damage. And we're going to send in some value. And let's take the health, and I'll minus equal the value. And then if the health is less than or equal to 0, then I'm going to do the this.gameObject. So this is the game object. Think about the game. Think about it like the game object in the hierarchy. Dot set active, and we're going to set that to false. So it's nothing real special here. It's just reduce the value. If we go below 0, then we're going to do some action on the game object itself. I'm not actually going to destroy the game object because the player object isn't a prefab. I don't actually have another way to instantiate that object without making it a prefab. So I'm essentially just going to turn it off. And then when we reset the game, that's why I had this set active equals true. So we basically turn the player back on. We make sure that we position him back in the center and then turn the game object back on. So that way I don't have to destroy it. I don't have to make the player a prefab if I don't want to. You could certainly make a player a prefab and destroy it and then reinstantiate it, but this is a another sort of potentially easy way to do that. So the set active piece is if I click on my player game object in the hierarchy. Set active is the check mark that's right next to the name. So that's all set active does. So if I say set active false, it unchecks it, player disappears. Set it to true, player comes back. So that's all this set active thing is doing. So for take damage, this is basically all we need. We're going to go to the enemy class now and actually figure out how to call this function, how to actually get it so we invoke this somewhere in our code. There's going to be a design note with this because the way that we're going to do it is not ideal, but it'll be sort of relatively easy for us for now. So in the enemy class, there's not a lot in here right now. We have start, which just chooses what speed this enemy is going to move at, and we have update, so every frame it's going to move down a little bit based on the speed. So nothing too complicated here. But the enemy does have, if I go back to Unity, and I go in and look at the prefab after we compile here. If I look at the prefab, we have a circle collider that's set to a trigger. By setting it to a trigger, it looks like it doesn't interact. If I go into play mode, it looks like it doesn't interact at all with my snowman. The snowman doesn't get hit by anything. It just sort of goes back behind stuff or whatever. We're going to set it up so that something happens when we get the trigger. So that we're going to sort of deal with that trigger because there is something happening in the background. It's just we're not sort of catching it at all. So back in the code, one of the other Unity sort of predefined functions, just like start, just like update, is on trigger. Should be on trigger enter. I can't see all the things here. Enter on trigger enter should be the 2D version. On trigger enter 2D. This is one of the standard functions. It's one of the things that you just have to remember that this exists. So the reason why I have the snippet here is because I have the snippet stuff downloaded in Visual Studio Code. This is when another object enters a trigger collider attached to this object. And this is the 2D physics version, which is what we're using. We're using the 2D physics stuff. This will run when the enemy collider hits another collider. My player has a collider on him as well. I'm using the box collider. So this function will run every time the two collide. The circle from the enemy, the box from the snowman. So I can even do a print, for example. So I could just do a print, and I could say collision. So if I run this right now, go back to Unity and this, we should see some stuff popping up in the console here. There you go. So it's running that code every time. As soon as there's that collision, the code runs. It doesn't run it more than once. It just runs it one time. So that's what we're looking for, because as soon as that happens, we need to do some stuff. We need to make sure that the player takes damage, and we can get rid of the fireball. It doesn't need to be there anymore. We can actually destroy the fireball. So I'll keep the print in there. One of the things we want to know, however, is it the player? What if we hit the ground or hit another collider, maybe the wall collider, for instance? Do we want it to also subtract from the player's health if it hits the ground? Probably not. So we need to determine what actual collider it hit. This is another place that tags come in. So if the let's see, it depends on. I think in the slides I had a different name for this here. So if other, so this is the other collider dot tag. If that's exactly equal to player, so if it's the player, the object that was hit, the other collider, if the tag on that object is player, then we know we've hit the player. So we need to take that player, and right now I'm just going to call it P. P dot take damage. And we'll put in however much damage this particular object does. So we should have a variable damage up here. So whatever we set that to be in the prefab, that's what gets sent into take damage. Now, I have an error here on the P. We'll talk about that in just a second. So if the collider is the player, we take damage, and then I can say game object dot destroy game object. Notice the difference here. I have a capital G and a lowercase g. The capital G is representing the class, which has a static method called destroy. Game object is actually this game object. So there actually is a difference between the lowercase g game object and the capital G game object. So I'm calling a function, a static function from the game object class to destroy this game object. So as soon as there's a collision, we'll check if it's the player. If it is, the player takes damage. Otherwise, well, there is no otherwise, and then it destroys. So if I hit the ground, that's not the player, but we would still destroy the game object. So that's the idea of this on trigger enter. As soon as you enter, as soon as the trigger happens, you run this code. This is where some of the style note comes in. Yeah, where do you get P from? That is a good question. So Nick, that's the style note here. That's the style note in my slides here. So there's sort of a couple things. Most of this sort of pop-up stuff is what I just mentioned. We have to have a reference to the player object for this to work. That's the P. So the design note. Should the enemy have a reference to the player? For a small game, this is going to be okay. And it's what we're going to do. So we're going to put the code in for P here in just a second. But this kind of dependency can lead to problems down the road. The questions you should ask when you're sort of making entities like this and writing your code is, should each fireball know about the player? Should it know what's happening to the player? Or should it be able to know what's happening to the player at any given moment? Maybe the answer is yes. Maybe that's okay. Maybe it's not. This is a situation where the game manager might be able to help us out as well. The game manager might be able to do that communication for us. The fireball might say, I just hit something with the tag player, and communicate that to the game manager, when then the game manager subtracts the health. That'd be using communication through the game manager rather than doing it directly. In that situation, you would never have to, the player would never know about the fireballs, and the fireballs would never know about the player, and they would never need to. So you'd have this decoupling effect, where if you went and changed the player or changed the fireballs, they would have no impact on each other, which is probably what you actually want. So we'll talk more about this type of thing in the future, this sort of decoupling, trying to make it so we don't have all of these references to all these objects in a bunch of other objects. So, for example, the fireball knowing about the player. Because when we start adding features to a game, those dependencies can come back to bite us. For small games, it's not going to be as noticeable, but as games start to get more and more complicated, it can really cause problems. It can cause problems where you're halfway through development and then you realize I need to rewrite this whole class because I have all these dependencies that I need to get rid of. Otherwise, I'm going to break stuff with a new feature. So as far as the design note goes, for now, we're just going to sort of keep it like this, and we'll add just a little bit of code to get the player in. But you want to make sure that you're asking yourself that question. Every time you put a reference in to, say, another object in the game, does it make sense? Is that what you want to do? And try to think about how that will affect in the future. Try to think about what effect that's actually going to have. So for our situation, we need this P, and that's a reference to the player. So up here in start, we can do that. In fact, we can do that in the exact same way. I'm going to open the game manager script. We can do that in the exact same way that we did for the game manager. So I can take this player line from the game manager, player equals game object, find game object with tag, player, get component, player. And we're going to think about what's happening now. So in start, I'm going to add this in, and I'm just going to call this P. And as a variable up here, as a class variable, I'm going to say private player P. So I've got my P right here. Game object, find object with tag, player, get component, player. So it's going to find the player using this. Keep in mind when this runs. This runs every time a fireball spawns. Every time a fireball spawns, we're going to be doing a find in our hierarchy. Is that a good thing? For our game, it's not going to matter performance-wise. But if you were spawning thousands of these things, and depending on sort of what other stuff your game is doing, this could take a reasonable amount of time. And it might be worth figuring out a different way to do it, for example. So we grab P for the fireball. It knows about it. It knows about the player, and so it can tell the player to take damage. So the fireball is the one doing the communication. It's telling the player, hey, you need to take damage. Right now, nothing happens. When the fireball hits, it just runs the code, so there's no explosion or something like that. We'll add those in using some particle effects. But right now, if our damage goes too low, it does set the game object to false for the active. So it should disappear after we get hit a few times. Let's see, Gabe, would it make sense to find the player on a collision? That way only the small fraction of fireballs that hit would do any lookups. Yes, you could certainly do that as well. So in this particular case, every fireball knows about the player. If we moved this down, for example, down here, so we look, see, oh, the tag that we just hit was a player. Let's look up that player and then run the actual run the actual damage calculation. That you should be able to do that as well. I don't see any problem with that at all. I'm going to put it back up here and start, but there shouldn't be any problem at all with that. So if I run, we'll still get the little print from the collision, and I don't know how much health I put in on any of this stuff. Well, let's see. Health-wise, I said 3. What did I say for? I may have had the fireball at 0 damage here. Yeah, so make sure the fireball actually does damage. That would be useful. I had the fireball damage at 0. Yeah, Nick, I'll go back to the enemy script here in just a second. So that one hits, this one hits, and then it's gone. So that's the, now I'm getting some errors. So it's saying object reference not set to an instance of an object. This is happening because each fireball that spawns is looking for the player again, and I've deactivated the player. So we'll have to think about how to deal with some of that. But for now, we know that damage is happening. We know that we're running that collision script, and we are having the player take damage, and when the player's health goes to 0 or below, we are setting it to inactive. So that's sort of our sort of initial sort of damage, kill the player sort of thing. There is stuff to fix, but that will be stuff that we'll work on some next week. So yeah, so Nick, here's the enemy script again. So our on collision enter, and then our find the game object and our private player. Make the reference to the player static. We could do something with the game object, for instance. So we could do something with the game manager. So the game manager, and I'll flip back here in just a second, Nick. The game manager has a reference to the player. So potentially the enemy could go to, whenever it does a trigger, for instance, like this, it could go to the game manager because the game manager is already a singleton. It could go to the game manager, grab a reference to the player, and tell the player to take damage, or we could write a function in the game manager that causes the player to take damage and just have the fireball send that information to the actual player itself. So we could do communication through the game manager, which is probably ideal. We have the game manager set up with references to the spawner, with references to the player already. there's not really a big need to have more references to the player floating around when we could just use the game manager for potentially what it's intended for that sort of communication, to sort of be the all-knowing, omnipotent game object, so it can actually handle some of that communication. And again, these are all design choices. These are all design things that, one way or another, if the end product needs to work. How exactly you get there, making some good decisions can help in the future. But for now, since we're going to keep it simple, keep it sort of as simple as possible, I'm going to sort of leave it as is, and we'll fix some of the issues that potentially come up. But for especially for the third game, that's a bit larger, we will try to make some good design decisions on those. So yeah, feel free to mess around with this some more. See if you can change it so that the game manager is the one that's doing the communication. That's a good sort of practice thing to do, because it's a very common situation, especially in smaller games. So that's basically the sort of damage stuff that we didn't quite get to last week. So not a whole lot of sort of code added in, but a little bit of sort of talking about these sorts of decisions and potentially the pitfalls that might come from it. So before we go to the visual effects graph, does anyone have any more questions on this one? Potentially, let's see, Kevin. So potentially in the enemy script. So potentially, so you want to make sure that you do have a reference to float in your to speed in your class, and make sure that in start you're setting it to some value. It doesn't have to. It can be basically whatever you want. But here we've done sort of a random value between sort of some min and max that we set. I could take a look at it after class as well, if there was something that got messed up. All right, so I'm going to close out this Unity project. If anyone has any questions or had a problem sort of adding that bit, I can definitely help after class, or potentially if you have time for office hours tomorrow, we can definitely do that. But I'm going to close out of this project. Make sure everything's all saved. And we're going to move on to the visual effects graph. So if you clone the project or just downloaded it as a zip, in the Unity Hub, if you're using that, you would say add, and then you'd go find the folder where you downloaded it, and it should open just fine. So mine is called VFX Example Project, which I think is what the repo is. So I'm going to open this one up. It'll take a few moments because it is loading some more stuff than a standard 3D project. It's loading all of the render pipeline stuff as well. You may get a window that pops up. When you open this, it mentions something about the HDRP, the high definition render pipeline. We'll see if it pops up on mine. Everything should be fine. It should show like a bunch of green check marks, but we'll see if it pops up here for me. The visual effects graph itself is, all right. So the visual effects graph itself is a sort of drag and drop node-based tool. If you've messed around with the shader graph before in Unity, it's the same style of thing. It lets you create some really cool, really complex particle effects super easy. You can do potentially millions of particles because these particles run on the GPU. It is complicated. There's a lot of different nodes. There's a lot of different tools. It gives you a lot of the same features as the regular particle system, but expanded. We're going to go look at the package manager here in just a second. If you open the one that I provided, Visual Effects Graph is already going to be, the package is already going to be installed, so it's not going to be a problem. But I will show you where that is anyway. So here is, so I got this thing that popped up here, HD Render Pipeline Wizard. It just says that there's a newer version, which I'm not going to worry about. But otherwise, everything else should all be configured. So if you have trouble with this, definitely let me know. If you're having problems I'm not sure because I basically took this project and pushed it up to GitHub. It should open for everybody. I would hope, since the other ones seem to have. If you do have a problem with this, we can try to diagnose that potentially after class. So everything here looks fine. So I'm just going to close this, and this is the type of thing we're going to make today. This is a visual effects graph particle system, and so we added, so I got a little thickness to whatever this thing is, this little spinning wheelie thing, and there are a bunch of particles in here. There's tens of thousands of particles in here. They look like little sparks or whatever, and we'll mess around with some of the stuff. I do have a post-processing volume on here, so it should be there for you guys as well to get the bloom and stuff. We will talk about post-processing in its own lecture in the future, but you should get some nice bloom and colors and stuff like that for this. The one that you're loading, it likely doesn't have this right away, although I don't remember if I left it in there or not. If you just have a blank project, that's fine, because we are going to make this. So mine over here is just called ring. You can sort of see the sort of selection on here, and really the only component is visual effect. We created the graph. So that's essentially where we're going to start. We're going to create the graph and then basically drag that graph into the hierarchy. So for now, I'm just going to delete this. So I just have basically a blank project. This is really only available, at least in non-preview version on Unity 2019.3 or greater. It does use the GPU. Like I said, if you are on battery power on a laptop, this is a battery hog. This is basically just constantly using the GPU. So not only are you using the GPU for Unity and anything else you have open, but also for computing stuff with particles. So it will suck your battery life down. So that is something to be aware of. As far as the package goes, back in Unity, if I do Window and I do Package Manager, it brings up something that looks like this. We should be able to do a search. After a moment, it's loading stuff from the internet as well. If I start typing in visual effect, I'm just typing in visual, you see that the visual effect graph is installed. So if you have a project, either a universal render pipeline project, a URP project, or an HDRP project, which is what this is, you will either have to find this to make sure it's installed, or I think it comes pre-installed with the HDRP anyway. So the big thing is, if you want to do a visual effects graph, make sure you have this package installed. On the standard 3D project, it does not have the capability to use the visual effects graph at the moment. And the universal render pipeline version is not as tested and doesn't have as many features as the HDRP. So that's why we're using this project, because it does have the HDRP stuff already loaded. Again, if you don't really know what I'm talking about with these render pipelines, that's fine. We are going to talk about them a bit more in the future. All right, so when we create a new visual effects graph, what we're going to see is what I have here on the slide over on the right. It's going to look quite different than the regular particle system interface, but a lot of the stuff is going to be similar in terms of like module type things. We just have different contexts. So we have a spawn context. We have an initialize context, update, and quad output. So spawn, think of spawn as how many particles? What's the rate of spawn? So that's similar to the emission module in the standard particle system. So a lot of these have sort of analogies in the standard particle system as well. So how many particles are spawned? When are they spawned? So if you have bursts or anything like that. The initialize context, so the second one, and these will always be connected. It's like longevity. Where are they spawned on some shape or on a mesh or whatever it might be? The velocity, how fast are they moving? So things like that. Think of it like starting values. So the spawn part is how the particles are spawning. The initialize is what are their starting conditions like, the velocity, their position, all that kind of stuff. Update is their behavior over time. Are there extra forces that get applied to them? You can do some color change stuff in here as well, although we'll deal with that in the quad output section. So there's lots of different stuff you can do in update. Many times, update is sort of fine being left alone. In fact, in this sort of circular, sort of sparky thing that we're going to make, we don't actually need anything in update at all. It's just the normal motion is all update's going to do, because we're going to make everything in initialize do what we want. And the quad output is the rendering. So the render module in the standard particle system is essentially this quad output. What should they look like? Is there a specific shader? If you're using a billboard, so just a flat plane, how should it face? Should it face the camera? Should it face the direction it's going? Things like that. So the contexts here do represent specific regions in the standard particle system as well. So we messed around with that last time, so hopefully you'll see some parallels between like set color over lifetime or set size over lifetime, things like that we're going to mess around with. So this is what you'll see when we create a graph. So I'm going to go in and create one, and then we'll sort of take a closer look at some of these little modules inside inside the context. So I'm just going to do it straight in the assets folder here. So I'm just going to right click. I'm going to say create, and there should be an option for creating a visual effect. So down about midway, there's visual effects, and I'm going to create a visual effect graph. And I can name it whatever I want to, so let's just name this. We'll have another one here. I'll call this ring 2. It's my second ring. It doesn't look like it did a whole lot other than create an object. If I double click on it, then it brings up the UI. So I have my spawn area, my initialized particle, and my quad output. It's already set up. It's already set up to go. Yeah, guys, for the still loading stuff, it's possible that it's putting in all the library things as well, and I think that's somewhere around. I think it's a few hundred meg of stuff that it sets up.
Quick question: do you have a visual effects or a visual effects graph?
So we'll do so it should be in. So if I right click and I say create, we'll do visual effects and then visual effect graph.
Thanks.
Now this already has stuff ready to go for a particle system. So we see in the spawn context, there is a rate. Initialized particle, we see a set a random velocity and set random lifetime. So the lifetime here is going to be, for each particle, would be between 1 and 3 seconds. The velocity will be random between the two values here for the X, Y, and Z. And for the output, the texture is a default particle. The orient, it'll be the face the camera plane. Size over life, it's going to get bigger. And color over life, it sort of starts out, if we look at the gradient here, it starts out a little bit transparent, turns white, and then goes back to transparent. So it's really already set up to sort of work, at least to create some particles. So I'm going to move this a little bit out of the way. And I'm just going to take my my visual effects graph, and I'm just going to drag it into the hierarchy. So here it is, right here. And that's the default particle texture, this sort of clock-ish looking thing. Actually, it's the sort of axes in a circle. And they're starting small, getting bigger, and then fading away. So that's what this is. That's what this is. This initial sort of standard particle system is representing. Now we can mess around with some of these individual pieces. So maybe I want the rate to be a bit higher. We do need to. Typically you do need to recompile stuff or at least save it. I changed the rate, but it didn't look like much happened. That's because my capacity is still quite low. So I can change this. We'll probably up this to like 100,000 or something later on. So now I should get particles spawning a lot faster. And I could even go even more than that. Sure, save it. And I'm getting just tons and tons of particles here. And there's not even a sort of slowdown, any sort of noticeable slowdown as I'm creating thousands and thousands and thousands of particles. Nick, how to access the graph. So once you create the graph, you can just double click on it and it should pop up. So again, that was the create visual effects graph, and then once it's there, once you give it a name or whatever, then you can double click, and it'll bring you to the UI. So that looks okay. It's not a ring for sure, but let's see. Mary double clicked. All I see is a box on the left and not those options. It could be worth zooming out because it might have been something might have been sort of over onto the side or something like that, because you can pan. So here I'm using a middle mouse button to pan, and then you can zoom as well. So the first thing I want to do with this, let's reduce the rate down a little bit, just so there's less particles spawning. The first thing I want to do with this is change the texture. I didn't provide you with a texture, but there should be a decent one built in for us. So if I click on the little circle with the dot to the right of the name on the main texture, it brings up a list of all these textures. A lot of these sort of came with the assets that come with the HDRP, stuff like that. The one I want you to find, and you can do a search for this as well, there's a little search thing, but the one I want you to find is Sparkle. So it should be right here. So Sparkle. That's the one I want you to find. So you should have Sparkle. I don't see any reason why there wouldn't be, even if you created just a starter project, just the HDRP starter project. This one should be in there. So that's the one that we're actually going to use to create our sparks. So called Sparkle. Again, you can just type in Sparkle in the search here, and you can find it. So I'm going to double click on that. So now I have the Sparkle texture. Doesn't quite look like sparks yet, but we're going to get there. One of the other pieces that we need to do is it's just pointing straight up.
Professor?
Yep.
I just see like a blank gray screen. I can't see any of the stuff going on.
In the scene view, or in the
scene view.
So potentially, let's see.
You have to drag it in the
So make sure that you do drag the visual effect graph into.
Yeah, it's in there. I mean, like I can't see the camera, like little like preview. I don't see a grid. It's just like totally blank and gray.
Gotcha. So if you double click on one of the items in the hierarchy, does it change the position at all?
It zooms. It moves to a spot. I'm not on the game window. I'm in scene. But it moves to a spot. It shows like the kind of like the directional arrows of like scaling and moving it and everything, but I just don't see any actual thing.
Yep. So you can turn on, if you check and see if your gizmos are on as well. This is going to show you things like camera, light. For this, it looks like a genie lamp for the visual effects graph. Does that? And then by that you can just press the gizmos button. Does that show any of the individual pieces?
It does not.
Okay. All right, we may have to, because it should just be a default or something thing. Try to quit out and come back in and see.
I have. I think at this point I might just have to reinstall. I think. Okay.
So I'm not entirely sure. It's good that it like moves around when you double click on stuff, but because typically there should be the grid and everything there. It's
I tried toggling the grid too. All right, I restall.
Yeah, we can. And I can take a look if you're still having the problem.
All right, thank you.
So. Nick, maneuvering the graph. So if you're in the UI for the visual effects graph, holding middle mouse button and moving will pan, and then zooming is the scroll wheel. Obviously, on a laptop without a mouse, it's whatever sort of key or thing you can do to get it to simulate the middle mouse with the trackpad if you're using that. It is more difficult with the trackpad.
You can also hold Alt and left click around with the laptop and pan around.
Yep. Yeah, with the trackpad, Unity is a little bit more tricky to navigate. Okay, so the pieces here that are going to be important for our little sparkles are the orient. We're going to orient So we're gonna face we're still gonna sort of face the camera, but I want to do this. I want to orient them along their velocity. So they are still facing the camera, but take a look at their rotation now. The direction that they're moving is how they're sort of rotated. So this is usually a pretty important one. Typically, if you have something like a spark or I don't know, something that looks like a laser beam or something, you want that rotated appropriately. So that's sort of the first one that we're going to mess with. Size over life is something that we're actually not going to use essentially at all. So if you want to delete one of these blocks, you can just right-click and you can say delete. So these now will always be the same size as they go through. We will use the color over life. For this, using a sort of a sparkle type coloring will give you something kind of like this. If you want to make a brand new one, so I'm going to do that. I'm going to go to a different one here. You notice the glow that showed up. The regular gradient here isn't going to give you that glow. When you open up a color like this, you're going to get your color picker. If you want to see the glow, it needs to be an HDR color, a high dynamic range color. To do that in the color picker, it's the intensity. So I can increase the intensity by 1, 2, by 3, by 4, by 5. Notice how the glow starts to come in. That's because of the bloom that we actually have in the post-processing, and that can be adjusted as well. And we keep going, and that's definitely a bit too much. So this is max intensity, probably not what we want. You can also use the little slider bar here as well. So we need an HDR color for this to look the way we want. So here I got some blue ones here, and notice in the actual gradient itself, it sort of shows this white sort of thing in the center, showing that it's an HDR color. And I can change all of my colors here to HDR. So I'll increase the intensity of each one of these a bit here until I get some interesting stuff. Down one. So our color over life is still just regular colors, but we increase that intensity piece. And because I have the post-processing enabled, that's going to give me the glow, the actual glow itself. And again, we'll talk about post-processing later on. I'll show you how to enable it, all that kind of stuff. Johnny from a few moments ago, am I on the game window? This is just the scene window. So I am still just in the scene window. That's one of the nice things about the visual effects graph as well, is that in the scene window, you can still see stuff. In the game window, it should show it as well, even without running the game. But in the scene window, I can see it as well. And I should probably, that's just making sure everything's mostly zeroed out. So you should be able to see it in here as well. So there's my color over life. That's okay, but they're not really looking to sparkle. They're not really looking to, I don't know, spark-like. They're a little bit fat. So I'm going to add a block to set the scale in just one of the dimensions. So I'm going to show you how to add your own block in here. You can come up to the name. So this is output particle quad. I can click on that, and I can say create block. You can also press a spacebar if you're sort of hovered over this or sort of selected on the actual context itself. You can press spacebar and start doing a search. So I want to do a scale, and actually we want to set the scale. And I'm just going to want to do it for one dimension. There is no set scale for one dimension, but we're going to look at the block here in a second. So set scale. So it adds this one in, and it automatically will scale in the X, Y, and Z. But there's a drop down for me to change the channel. So let's say I just want to scale in the X. And maybe I want to drop this down to 0.1. That looks a little better. That looks a little closer to what we want. And I could even scale it down even more. Okay, maybe that's not quite what we want. It's sort of the aliasing here is sort of giving us a little bit of a problem. But you can choose an axis and decide you want to scale. Maybe I want to be a little bit thinner. I don't know, maybe something like that. We can always mess around with it. It's not a hard thing to do. So that's the idea of taking whatever texture you're using and then scaling it. You just use a block. We looked up scale, or in this case set scale for the block, and I wanted to scale it in the X, and I set whatever value I wanted. So I made it real thin. We could also stretch it out if we wanted to as well. We could scale in the Y and give it a larger value if we wanted it to be longer. Again, a lot of this stuff is going to be aesthetics. Like I said, with the original particle system, you could play around infinitely with how this stuff looks. So I'll probably leave it like this for now. I may increase the color intensity. Since we now have a smaller graphic, maybe I want the bloom to be more intense so that the smaller graphic gets some nice bloom. So in my color here, I go back to here, maybe I increase the intensity a bit more. And again, these are things that you just go around tweaking. And I may need to mess with the, looks like there's some aliasing issues with the bloom as well. So we might want to have the scale up a little bit. So we'll sort of mess around with this as we go on. So that's not looking too bad for Spark wise. We may put in some set scale Y as well. Maybe we'll see. But I want this to be in a circle. I don't want this to just emit from sort of a single point like this and just give it a random direction or a random sort of starting point. So up in the initialize, for the initialized particle, that's fine for the lifetime. Some particles are disappearing earlier, some particles are disappearing later. That's fine. We can change the velocity stuff if we want to. I'm just going to leave this as it is for now. If we turn this off, so with the check mark, then they're not getting any velocities at all. So we definitely, to see what's going on, we probably want this on. For the lifetime piece, we want that on as well, so that we know that they're going to be alive for some part of the actual calculation, for some part of the actual simulation itself. I'm going to add position to this. I want them to spawn in a different way. So if I hover over or sort of just select the initialized particle, I press spacebar, or I right click and say create block, I'm going to look up position. There's a few of these. There's this AA box, circle, cone, depth, line, sphere, torus, many of the same types of emission shapes that we saw in the original particle system. So I'm going to select circle. So now its position is from the surface. It's randomly spawning from the surface of this circle. And that is what it looks like. And I can change this to say volume, and it would spawn from anywhere within a circle. I'm going to keep it at surface. I'm going to keep the spawn mode random. But notice we have this arc circle here. And actually, let's increase the rate, maybe up to 1,000 or something. That should give us a little better indication of what's actually happening here. So it's spawning in the circle. Maybe I'll decrease the time that they're alive as well, so there's not nearly as many sort of interfering with the center. So I got a lot of particles right now. So it's spawning along this outer ring. The arc circle is giving us a little bit of information about how much of the circle it's spawning using. This is in units of radians, so that's why 2 pi radians gives us the 6.18. So I can decide how much of the circle I want to use, so we get something that looks like this as I move this arc. If I want to change information about the circle, there's a drop down for the circle, and I can change the center, and I can change the radius as well. So if I want a circle bigger, smaller, whatever. The reason why the particles are all going in different directions is, again, because our set velocity random. So we still get a random velocity. We're spawning on the edge of that circle around the entire thing. We're given a random velocity. Notice in the Y, it's going to always be positive. So just the default thing here, it's always positive in the y. That's why they're always, at least in some way, moving up. You don't see any particles actually moving down. Now, this might be sort of good enough for something. Maybe you use a particle for fire or something, and then you have something that, I don't know, you're making a game where a car jumps through a fiery ring. This would probably be pretty close to working. You change the texture to a fiery looking texture, adjust some of the colors, and you're basically done at that point. But we want that sort of ring that makes it look like there's something spinning, and the particles are sort of shooting off in that sort of the direction that this ring thing is spinning. I'm not actually going to spin anything. There is no animation going to be done on this circle or anything like that. We're essentially going to fake it, but it is going to end up looking pretty good. We're going to add a velocity. So right now, again, the only velocity is a random velocity. We're going to add a velocity. So in our, and as you add more blocks, things here can overlap. So I'm going to take my update and my output quad and move it down. So I just highlight it and then click and drag. And then in my initialize, I'm going to give them a velocity. So I'm going to say create block. And it's not going to be an angular velocity. It's just going to be add velocity. So we could do angular velocity, which is a rotation. I don't want that. I want just add velocity. So it's a very simple thing. It's just an XYZ velocity. So if I wanted to add a negative velocity to Y, now they're all moving down. If I wanted to add something in Z, like this, now they're all moving in the Z. They still have some spread because I have the random velocity set, but now they're moving in the Z. And so you can imagine you can still get some pretty cool stuff with some very simple changes to the VFX graph. So imagine if these were longer or something, you could get some pretty cool visual effects just out of something like this. But that's not what we want. We want the spinning thing. It is easy when you're playing around with this to get sidetracked and be like, oh, actually, that's actually pretty cool. So be mindful of that if you're on a time limit for something. So Jonathan, initialized particle, yes. So right here. So the standard ones that sort of came with this were the capacity. You can't get rid of that one anyway. The set random velocity, set random lifetime, those were just standard. They came with it. I did reduce the lifetime a little bit. And then I added the position for doing stuff with the circle. And I just added the add velocity block as well.
When you're editing on the right, how do you? I'm really struggling trying to move between blocks and kind of like you have to zoom in and then focus your mouse on the area, and
so yeah,
I kind of lost mine.
It does zoom to mouse to the mouse cursor when you're messing around inside the UI here. If it's completely gone, you should be able to. Yeah, I don't know if there's I haven't checked if there's a setting in here that will sort of bring you back, but you should be able to zoom out quite far, and then hopefully you'll be able to see it if it's around. Let's see. So that gives us, yeah, we don't want to deal with that.
Mine's caught up on the top. I don't know why. I only have half of it on the top there. It can't get up there.
Gotcha. So see if you can select it. So you should be able to drag select. See if you can select it and see if you can move it move it back. I don't know if closing out and going back in will recenter stuff. I'm not actually sure.
Professor, just sorry, I got it working, but how did you get it to not look like those weird circle things?
So that was
the actual particles.
Yeah, so that was our in the output particle quad. So the output, essentially the output context for the main texture. I clicked on a little circle with the dot in it, and I found sparkle.
Thank you.
Yeah, then the only other thing I messed with in the particle quad stuff was setting the scale in X, messing around with the gradient, and then making sure that they were oriented along their velocity, so they were rotated along the velocity. we're actually pretty close to being being done with this. There's only a couple more things we have to do, but it relates to the node piece. So we have contexts, we have the blocks within the contexts, and then we have nodes. It's a node-based editor. If you do something outside of a context, so like out here, if I right-click, it says create node. This is where you can do some math stuff. And if you've messed around with the shader graph at all, it's exactly the same as the shader graph. But it deals with the particles and their attributes rather than like textures and stuff like that. So I'm going to type in the search here for creating a node, I'm going to type in position. And we're going to use get attribute position. Yeah, Gabe down here in the color gradient color. After you choose your color, then you can increase the intensity here. So you can go up by values of 1, or you can use the slider to go up, and that should trigger the bloom that's in the post processing that I'd set up in here. So this is just an attribute. Each particle has a different position. It's spawning in a different place. This is where a little bit of linear algebra comes in, or at least a little bit of linear algebra knowledge comes in. We actually talked about what we're just about to do. But you may not remember, it was in one of our lectures, I think when we were talking about vectors. Because this is a position, this is a XYZ position. And I can grab the individual X, Y, or Z individually if I want to, but I'm just going to leave it as a vector. So you can think of this position as an XYZ value. I'm going to add another node, same one. So I'm going to do the get attribute position. So I have 2 of these. But the location, I'm going to say source. So the current position of the particle and the source position of the emitter. Where's the source of the emitter? 0, 0, 0, the center of my circle. Yeah, they're spawning on the edge, but the position itself is 0, 0, 0, the center of my circle I'm spawning on the outer area of. So that's my source. So this is 0, and this is the current position of our particle. With these 2 attributes, I can get these to spawn so that they're always facing away from the circle. When you take 2 vectors and you subtract them, so if you had like a player and an enemy and you wanted to know what direction does the enemy have to go to move towards the player, you subtract the 2 vectors. So all of these nodes, and in the shader graph, in the visual effects graph, all of these have subtract. So we're going to subtract. Now here it says float. It says I'm subtracting floats, but as soon as I put in a connection, then it's going to subtract vectors. So you can click on the little colored circle. So let me do that again. You can click on the little colored circle here and just drag a connection into the input. So there's always inputs on the left, outputs on the right. So the output of this subtraction is right here. So that vector subtracting the source, taking the current position and subtracting the source gives me the current vector. Now for the velocity, let's just plug this in. I'll take the output of this subtraction and plug it in here. Not too bad. If I turn off my random velocity, then it's going to be totally uniform, other than the random particle generation. So now we're shooting directly out from the center. They're spawning, and their velocity is directly out from the center. So doing a little bit of math, understanding a little bit of the linear algebra behind it, lets me come up with something like this, which is actually quite useful if I want to spawn directly from the center of my circle, or at least be velocity directly from the center of my circle. The random, the set velocity random, the reason why that was causing a little bit of stuff problem down here at the bottom is because, remember, we always give it a positive y velocity, so it's always going to have a little bit less motion down that direction that it has up here. So we can leave this on, we can turn it off, we can change it, we can do whatever we want. But for now, hopefully you understand why this is now spawning out from the center. So that's because of these things here. So I'm going to disconnect this. And let's just turn the random back on so we see something. And you can multiple select these and move them all at the same time. It's fine. But what do I want to do with this now? They're all spawning from essentially velocity moving away from the center. Well, what if I just rotate them by 90 degrees? So I'm going to do rotate 3D, because we're in 3D space. And I'm going to plug my position in here to the position. So my subtracted vector is now going into the position, the input position for the rotate 3D. And I need to choose the rotation center. That's just the center here. In fact, that's just the position source. In fact, I could put this and put this one in here as well. The center of the circle is already 0, 0, 0. So I actually don't need to change this, but this would be the center of the circle. The rotation axis, X, Y, or Z, or more than one. If we look at how this is set up, if I look at this thing head on, I'm looking through the Z axis. So this should probably be Z, although I don't remember for sure. So we'll mess around with it if it's wrong. And I want to rotate by 90 degrees. And I'm going to take the position and I'm going to plug it into the velocity. Now we're getting something interesting. I'm going to turn off the random per particle here. Now we got something that looks like sort of a spinning circle, and you got these sort of sparks flying off as they're being created. It's still 2D. There's no thickness to this. It's completely two-dimensional. But it doesn't look too bad. So if we want a little bit of thickness, we just need to give it a little bit of Z velocity. So I'm going to put the random back on, but I'm going to set the X and the Y to 0. And I'm going to increase the Z in probably the negative and the positive, and see how that actually the Z. No, we actually don't want the Z. We want the X and the Y, not the Z. The Z will make it go into. Now, I think the X and Y, we can spread it out more if we want to, but I think Z is good. We don't want to have it too large. So maybe we'll put it back to where it was before and see how thick that is, and then decide, do we want to change it at all? So back over here. So there's a little bit of thickness. If that's too thick for us, then potentially we can drop this down again as well. This. Here, a little bit thinner, but still has a little bit of that thickness to the rank that we're simulating here. So a little bit of math got us a totally different effect than what we were getting before, and it's just a matter of realizing that the velocity is just a vector. We can create a vector by looking at the center of the circle and where this particle's spawning, create a vector in that direction, and then rotate that vector by 90 degrees. So that we're actually spawning and sort of shooting a tangent to our spawn location on the circle, and then adding that velocity. And then to get a little bit of thickness, put a little bit of velocity in the Z direction so that they're not all in the same plane. So that's basically it for the particle system. It's not too complicated, but it does take a little bit of getting used to. Some of these sort of blocks, it might take you a little bit to find the correct blocks that you want to use. Notice we didn't do anything in update particle. We can add something in here if you can add things in here if you want to. They are set up to to only have blocks that can go in that particular region. So if I want to grab an attribute or something here, I can do that, and that is only relevant to the update. There is collision with these, but it's all collision in this, not with your own game objects from outside. We can add forces to things. So if I wanted to add a gravity force, then we get something like that. So it's actually 9.8. So that's why we're not getting a whole lot of interesting stuff happening there. But you could throw something in maybe a little bit smaller.
Could you go over how you got it to glow again?
Yep. So get rid of the gravity here. So the post-processing should be set up if you download the one that I had linked. So in here in our gradient editor, when you pick a color, so whatever colors you have picked out, the intensity stuff is at the bottom. So by increasing the intensity, you can get more sort of glow to happen. So the intensity goes from -10 to 10. The higher the intensity, the more glow you're going to get. And I can show you the post-processing profile here as well. There's a few other niceties you could add in here. Stuff like do some over life things with a curve. So set it up so maybe the scale in the Y changes over time or something like that. So it starts out longer and then gets shorter as time goes on. So there's plenty of those things that you can add in here. As far as the post-processing goes, it is set up here. So in the hierarchy, you should see a post-processing volume. Bloom is one of them in here, and you can actually change the intensity here as well. But you do have to have an HDR color. With no bloom on and HDR colors, then this is what it looks like. So not what we want. And then you can also, there's other things that aren't activated here, like you can change the tint of this stuff easily as well. Typically, you keep the tint at white because you want the particle color to influence the color of the bloom. But if you want to have an extra tint to it, you can actually do that, which is kind of cool as well. And there's a few other things you can do. But the only post-processing that's in here from the post-processing volume is bloom and tone mapping. And the tone mapping is using a standard film industry tone mapping. Again, we'll talk about post-processing, but I did want to point out bloom today, since that's what gives you the sort of glowy effect. So that's your sort of basic intro. There are also tons of tutorials about how to do interesting effects with these. I've looked at like firework ones as well. So you can actually trigger events to happen where when a particle dies, it triggers another particle system to happen. And so it's a whole new particle system in your graph like this. And then you say, when a particle dies, spawn this particle system. So you can get little particles flying up. They die, they run out of life, but then you spawn an explosion particle system from that. So you can go very, very complicated in here to make really cool, complicated particle effects without having to use tons of separate game objects with different particle systems like what we did last time. Last time we had two or potentially more particle systems to have sort of a central explosion and a ring that went out. In principle, you could do something similar in this, but only have one shader graph or one VFX graph set up for that. So yeah. So this is, I don't have slides for going over all of the stuff that we just did. So in the settings folder, there's a VFX folder, and the original ring that I created is in there. So you have access to the complete ring that I showed at the very beginning, and this one has all of those little pieces as well. It has a couple of other sort of things in here too that you can mess around with, but it has set scale X over life, so it actually changes some of the X over life, and it has the set color and all that kind of stuff in here. It has a little bit of turbulence too, so you can mess around with that and see what that does. But it's basically the thing that we just wrote. I think this one, yeah. I think I was messing around with some more stuff. So there's the position, the position stuff in there, and then it goes over and does all this to get to the velocity. But I also added some extra stuff in here as well. So feel free to play around with that to your heart's content. The colors here are a little bit different, but yeah. So I can see if I can help some folks out with potential issues you had. I didn't really intend to go the whole time today, but the visual effects graph is pretty fun to play around with. And I'll see if I can sort of find some other good tutorials. There is a lot of crap tutorials out there, but I'll see if I can potentially find some other good ones and throw them in the resources section as well. But that is basically all for today. So have a good weekend. We're going to work on Volcano Island again on Tuesday. After we finish Volcano Island, which will be soon, then you will have this assignment associated with it. So we'll talk about that next week. Otherwise, I have office hours tomorrow, and I can stick around for a little bit, but I do have another meeting at 2:30, so I guess I'll stick around a little bit, but I do have office hours tomorrow in case you want to talk then. Otherwise, see you guys next week.
Thanks, Professor. Have a good one.
Thanks, Professor. Have a good one.
Thank you, Professor.
See you guys.
Thank you, Professor.